Hello, everyone. My name is WANYAMA Edgar Francis, and I'm delighted to be given this opportunity to present this topic, interpretable machine learning for students' performance prediction in STEM subjects in Ugandan secondary schools. Yeah, and by STEM subjects, I mean the acronym STEM stands for science, technology, engineering, and mathematics. Yeah, and below are the authors, I myself, Wanyama Edgar Francis, alongside my colleagues, Ulongo, Michael, Aineme Wazishina, and Tibesi Badanka. Yeah, so in this presentation, I'm going to be discussing the topic interpretable machine learning for students' performance prediction in the STEM subjects in the Uganda secondary schools. So the main issue we are looking at is performance prediction and interpretable machine learning for the case of this presentation. Yes. Uh, so to start with, I'm going to take you through the contents of the presentation. And one of them is in the introduction. We shall first have the introduction about this topic. Then after that, we shall have the problem statement. Then after the problem statement, we go to the related works. After the related works, you go for research questions, then the objectives, then the methodology, then the experimental or simulation results. After there, we shall go to the conclusion. Then after we take a look at the future research direction. Thereafter, we go for the references. Then finally, the acknowledgement. Yes. When it comes to the introduction, we are talking about interpretive machine learning, and we see that it has gained increasing attention in the recent years, that it is able to develop more transparent and accurate models, meaning that transparency is like models that are actually easy to understand by people. Yeah, whereby people are able to understand the decisions made by such a model. Yeah. So interpretable machine learning has the potential to provide valuable insights into the factors that influence student performance, particularly in these subjects, the STEM subjects, by using interpretable machine learning techniques, which is possible to identify key predictors of student performance and inform interventions, to improve the outcomes of students in STEM subjects. So we shall explore the use of interpretable machine learning for student performance prediction in STEM subjects in Ugandan secondary schools, with the main goal, this goal of improving access to education and opportunities for students in these subjects, the STEM subjects. Thereafter, we got the problem statement. So the problem our research is trying to tackle is the lack of interpretable machine learning models for students' performance prediction in STEM subjects in Ugandan secondary schools. So why is it a problem, and how is it a problem? It's a problem because there exists some other prediction methods apart from interpretable machine learning, which are traditional. And for interpretable machine learning, it helps. It is good in a way that the decisions are understood. But here, the decisions are not understood. They're not transparent. The predictions are not transparent. For the predictions for students' performance are not transparent. Yet here they are transparent. And even the traditional methods are often subjective and may not actually predict future success. So you see that the use of machine learning in Uganda is still very, very new. And this means that there is lack of understanding and expertise in the area of machine learning here in Uganda. So to address the above gap, our research suggests that providing schools with necessary resources can actually address that gap and even support implementation of interpretable machine learning models for predicting students' performance. We can support the implementation of those models in order to address that gap. The related works, we see that this paper, Interpretable Machine Learning for Students' Performance Prediction in Higher Education by EDGAR 2014. This one shows that a study used decision tree, a rule-based models to predict students' performance in Brazilian university. And it found out that these interpretable machine learning models were able to achieve high accuracy and were transparent. We see that also predicting students' performance in higher education, this paper this research by SR Constantis, and this used a number of interpretable machine learning models, including decision trees, based models, linear regression to predict students' performance success in the Greek university. And the authors found that these models were able to achieve good performance and were able to provide insights in factors that influence student success. When we say the research question, we say how effective. One of the research questions is that how effective is the machine learning model at predicting students' performance in subjects in Ghana secondary schools. Another one is what is the potential impact of using the machine learning model on improving students' performance in STEM subjects in Ghana secondary schools. And another one is what are the challenges and limitations of interpretable machine learning for students' performance in STEM subjects in Ghana secondary schools, and how they can they be overcome. Then what is the potential for using interpretable machine learning to support decision-making and intervention planning in the context of STEM education in Ghana secondary schools. Then these research questions will help us also formulate the research objectives, because that's where we get the research objectives from, the research questions. And one of the objectives is to develop and evaluate machine learning model that can actually predict students' performance in STEM subjects in Ghana secondary schools. Then to assess a potential impact of machine learning models on improving students' performance in STEM subjects in Ugandan secondary schools. Then the third one is to identify potential challenges and limitations of using interpretable machine learning for students' performance prediction in STEM subjects in Ugandan secondary schools, and suggests the ways to overcome these problems. Then lastly, to explore the potential for using interpretable machine learning to support decision-making and intervention planning in the context of STEM education in Uganda secondary schools. Then the methodology, this one simply shows us the steps that we shall take in order to come up with a model that will predict students' performance in a secondary school. And one of them is the very first step is data collection. This is where we shall collect. We collected some data from a secondary school, and we are still in the process of collecting it. But we also have some other sources that we got online, some other data sets we got online. And this one is very crucial because you can't predict without data. And then the data processing includes data cleaning, feature selection, and data transformation. Where data cleaning, we are able to remove the errors and make the data consistent. Inconsistencies and errors are actually removed because the data needs to be accurate, such that it can be used and give accurate results. Then the feature selection, this is where we shall select the relevant features for prediction. And the data transformation, this one involves converting data into a particular form such that it can be used for prediction. And here we see that we shall be having some categorical data that we shall encode into numerical data under here, under data transformation. Then when we come here, model development, we see that we shall split the data into the training set and the test set. And that this purpose for data splitting is to evaluate the model's prediction. And after here, we shall use the training set. We shall apply the machine learning models on this training set to see how the results they give us. And even we shall, after that, we shall validate the model, then apply the interpretability methods. Then later, we shall come and evaluate the model using the test set, such that, and we shall use the various evaluation metrics, such as recall, such as accuracy and precision, in order to come up with the model. Then later on, we shall come here on, we shall deploy the model, and the steps that are under there. I think we shall integrate the model in our web application and load. We shall write the code that loads the model into the application and gives the necessary predictions. Then after that, we shall deploy it to production. That's what we are going to do. Then the expected results, we expect improved accuracy, and this will help reduce the number of false positives and false negatives. By the false positives, this is where the false positives is like the number of students. Okay, it will help reduce the false positives and false negatives, where the false positives is where those people expected or predicted to pass, yet in actual sense they will fail. Then these are people expected to fail, yet in actual sense they might pass. Then here to increase transparency, or models will actually be the model will actually be able to be understood and will provide insights in factors that influence students' performance and can help these educators understand the challenges the students face and they can adjust accordingly. Then improve fairness by using the interpretive machine learning. I think bias on predicting students' performance can be reduced, which will in turn ensure that all students are given equal opportunities regardless of their background. Then enhanced decision is related to the transparency. Since there's increased transparency, yeah, then decision making will actually be very, very improved. Then in conclusion, we say that it is very important that the machine learning models predict, well, it's very important to consider these models, the interpretability machine learning models when predicting students' performance, because they understand the factors that contribute to the students' success and can help educators to make informed decisions about how they can support the students. Yes. Uh, then the future works we plan to expand the scope of our research. Currently, our research is only in Uganda, but with time we plan to take it as far as East Africa and expand to South Africa, even West Africa and Central Africa, such that we can improve education system in our mighty continent, Africa. Yes. Then acknowledgements. I thank God who has kept me alive and has given me this knowledge, the knowledge to make this research. And also like to thank and give sincere appreciation to my one and only supervisor, Mr. Galiwango Marvin, for the guidance and tireless efforts he has put in to ensure that we produce the quality work regarding this research. Thank you so much, sir. God bless you. Then there are references, and I think this is the end of the presentation. Thank you so much, people, for listening. God bless you. Have a nice time.